Hey guys, welcome back to my channel, and in this video I will going to show you how you can proceed from the RTL to GDS. This is it is learning type of video. You can learn it in the short. What are the steps which are involved from the specification to the GDS to design a chip? You can see it. Okay. So first up, I will cover till the from the specification to logic equivalence check, which is the part of design, and then from after that I will show you from the backend design, like from the physical synthesis, physical design, right? So first up I will show you in this video, and then second part I will combine with this video, and then I will record later. Okay, so first I will show you. So first thing is you have to take some specification, like if you go to Intel, if you go to AMD, you will give them the specification that I want this type of design, this much of specification I want, then they will design for you. Okay, in the same way, I am designing a counter which will count 8 bit. Okay, so first we have to write first we have to design the counter. For designing we use VHDL, Verilog, or high level language also, but in this case I will use Verilog. Okay, so I will show you all the things step by step. Please be with me and you will learn at least something. Okay, so which will help you in some interview or learning also. Okay, see, so this is counter, right? So I will show you RTL design of counter. Okay, see, so this is a Verilog code for counter. If you are new, go to the basic of Verilog code. I have already designed in the playlist. You can see. If you are middle level, you can see by seeing, you can say that it is 8-bit counter up counter. Okay, so this is the design has been designed in the Verilog. Okay, the next step is to verify this design. Okay, functionality we have to verify. Okay, for verifying, I have to uh, for verification of this design we have to write a test bench. Okay, we have to write a test bench, and we will give it a stimulus to that design counter, and it will check the functionality. Okay, so for that, we will go to the functional verification. Okay, so I am going to FBA, right? So this is the folder for functional verification. So you are seeing that this is a counter, which is the RTL code, RTL design of counter, and this is the test bench for verification, right? So I will open once for that also. Okay, so this is a test bench, you can see, which has been written, and it will generate a clock reset signal. Based on that, it will give the output. Okay, so I'm not going in details because the video will be longer. If you want that video from the step 1 to step last, I can make it step by step with the 5 minute 10 minutes video of each. Okay, so now for what, for this verification we have to go to the there are two tools are in the cadence, Zelium and there is incisive. For this case Zelium is not available, and then we will go for incisive. Okay, so I will invoke that tool, TCS. So okay, so there is a command to invoke that Zelium, or I will show you. Wait, let me check. For invoking that incisive or sim vision, you have to write iron, and then you have to give the your design. Okay, counter dot v is there, right? And then you have to give the test bench also. Okay, counter underscore and then tab test bench is given. Now you have to write dash and then access. to access, and then RWC. You can search in the details about these all the terminal. Otherwise, if I will make the full video, I will explain you the whole process. Till now, I'm not going for this. Okay, this is for GUI, and this is for okay. Now see, in the terminal, it is all verified. It is showing module, register, vector, always block, and these all what are the in the test bench and module. Okay, but you have to see the functionality in the GUI mode. Okay, when you will invoke that tool, if you will invoke that tool, then you will see two window will come. Okay, so first is for this is second one is terminal, and this is for okay. For what, for this what you have to do, you have to select that counter test, that is test bench, and then click here. Okay. See, the counter is running. Okay, so it is running, the clock has been given till always, there is no stop, so it will run. Okay, I want to show you some part that how it is counter is counting. Okay, so I will pause, and then from here I want to go for some part of the time. Okay, from 0 to, suppose we want to go for 200 nanosecond, right? Then you will see this is clock. Okay, this is clock, and this is the count, and this is reset. So when reset is 00, there is no counting is happening, right? And then when it get 1, and then at the negative positive edge of clock, as what we have written in the RTL, according to that this will work, right? So it is counting 0 1 2 3 4 5 6, and it will go till 4 bit. Okay, so in hexadecimal it is showing like that. Okay, so functionality wise it is correct. Now we have verified our design, that our design is working very fine. Okay, so we have to finish this step. Now I am going to finish this, right? So functionality wise we have tested. You can also see in the terminal there are many commands using terminal, you can see it. Okay, I'm not going in the details. So this is the verification part we have done here, right? I want to see. Okay, so now what I want to tell you, we have gone from the RTL design, and then we have written test bench and verified in the sim design. And now what we will do, we will check the coverage. Coverage is also a part of verification. In coverage it is code coverage, block coverage, many coverage is there. I don't want to go in the details, but I will show you that how coverage will tell that okay, our design is how much it is covering, these all things are happening, right? So for that you have to again what you have to do, the code which I have run, so what code I have run here, the same thing you have to run, right? For coverage you have the tool is IMC, I think IMC. Okay, and then for here you have to do COVERAGE coverage, and then okay, so it will open another tool. The tool will be open the same. Okay, same vision, but for coverage analysis we will open IMC tool. I will show you how to open that. So for coverage analysis, what you have to do, you have to click on, you have to click on this. This is coverage analysis. See, you have to click. So it is telling that you have to simulate first. Okay, so what you have to do, you have to go there, and then uh, in the web form you want to run, and then okay, now running. It is getting run, right? Now you want to see the coverage. So for that you have to go here. Okay, so I have to stop now, right? See, it is written IMC. So you can see that instance coverage, contact test, these all over grade are there, right? If you want overall coverage, how much overall covered? 48 among 52, 24 among 26. So for that you have to contact test. Okay, so click on the block, then you will see code block are there, source line. If you want to see the source code for this, see, if you can see here, toggle, the clock rate is able to, like it is getting covered 100%, and count is getting covered 100%, but reset is not getting covered. Okay, so from here, I want to say in the short, from here you can analyze all the coverage what are used for the verification. You can check it. I'm not going to show all the things, right? So this is for coverage analysis. So there are some like block code coverage is there, block coverage is there. Many things are there. Okay. So this is like I wanted to show you that how you can see the coverage, how much coverage is going on, right? So I will show you the next step, right? So I'm going to exit this. So for simulation we have used SimVision, and then for coverage analysis we have used IMC. I am going to exit this all. Okay, fine. Till now we have done till coverage. Now what we will do, as we have done coverage, we will go to the next step, which is synthesis, right? So I will go to the synthesis directory, and then as you know, synthesis is the process of converting the RTL design to the netlist. Okay, so this is the tickle file I have. Okay, so for that synthesis we have to invoke the tool, that is Janus. So I am going to invoke that. Okay, my audio may be not clear, or some maybe noise may be coming, because I am recording directly from the laptop. I don't have microphone exactly. Okay, so sorry for that, but learn it. That's the main thing. So basically for synthesis, what happens? Synthesis is a tool which will take input your design, and it will take a library file which having the standard cell, and it will convert that your RTL to the netlist level using the library. I will show you. Okay, so now for running that tickle command, which in tickle already there is there some of the command are there. for synthesis is like three-step process: elaboration, generic mapping, and optimization. These all things is which is written in the this TCL file. Okay, uh, so genus F and then S of TCL. So see how it is running. So actually it is running in the terminal as well as it will show you in the GUI also. Okay, because GUI is written in the article file, so it will open GUI. Or if it is not written, we can open manually also. So these all processes are happening for the synthesis. You can see. Okay, so synthesis has been done, and I will show you that netlist file. Okay, so first I want to show you the GUI. Okay, for GUI opening, click GUI. So it will open the Genus GUI, and here you will see the design. So if you want to see the schematic of that design, so you can see the counter which was written in the RTL is converted to the schematic from the with the use of library. You can see DFF RX1, AOI to BX1. These all are taken a standard cell which are taken from the library. Now if you want to see the okay HDL here, okay. Actually, I want to show you that how it looks. This is counter.b. See, this is the RTL code for counter, right? Now I will open that netlist, and then I will show you that how the RTL is getting converted to a netlist, right? So for that, we will open. Okay, manually I will show you, right? So as you have seen that schematic is like this. Sorry for this. Then I will show you. I'm exiting this. Okay, so ls when we have run that article, we have already given two folder. There it will be the output which will having a netlist and there will be one reports where you can see the power area, these all things. So I am going to open that directly and I will show you. Okay, so see in the output there is like SDC is there, delay is there. So SDC because a counter having clock. Okay, so clock will having some constant of uh, like how much delay will be there, rise time, fall time. These all things will be. So these all are written in the HTL file, which is I will show you one second. Okay. For this time, you see the net list. Okay, I will show you the net list. Okay. See, the RTL which was written was very simple and which was very like 7 to 8 line code was there. But if you see the netlist, which is like module counter, and it is these all are standard cell which has been taken from the library to design the counter. Okay, and this will be used for the physical design, right? So this is the main thing like synthesis is giving. Okay, so this was like output. If you want to see the report and the job, you can also see. So cd and then report. So I will show you in the first way. So see, this is area report, barber, timing. These all are. So I want to show you one this report. Okay. So you can see the how report area. So how much area is taking? Okay, total area. There were 21 sale was there, and area which is taking 72, which may be macro or whatever. Okay. So same way area timing is all will be there. Actually, I have to design the video which will be in the part. step by, because in one video you cannot learn properly. Okay, so that's what, no problem, just I am giving you overview. Okay, so I want to show you the constant. Okay, see, the clock is there, clock, and then period is 10 nanometer, nanosecond, sorry, and waveform is from 0 to 5. It will like and their rise time, fall time, these all are written in the tickle, yes, in constant file. Okay, so whatever the clock will be there, it will be based on these all. Okay, so this was I wanted to show you about the SDC. Now we have completed till synthesis, and you have seen the netlist also. Now next step is DFT. Okay, so we will insert a scan chain in that our netlist, and with that scan chain will be used for the verification. And in that there I will show you, right. So now I will go for DFT, right. Now see, for DFT there is also a tickle, which is all are written, the command are written in the tickle. I don't want to show you because I will make a separate video. For now this will be short. Okay, so for this what you have to run again, invoke that tool. Okay, now for DFT what you have to do is Xenos F and run this tickle, then you will see something. Wait for some time. These all processes are happening. You can see one by one, but for now I'm not going to tell you all the things. Sorry for that, but you can understand the process. Now I will show you. In the original netlist, you may have seen the D flip flop, right? But you have seen only there was only one which this connection which was missing. Now if I will click here, it is showing. See, this is a scan in. Okay, and this is a scan in one. So like it has using DFT we have inserted a scan flip flop in the design. Okay, which will be used for the verification. So you can see this a scan input is there, right. So basically DFT is used for that. Okay, so I can show you the netlist also. This is the schematic, if you want to see that. Okay. Go back. Okay, I'm not able to go, no problem. I'm exiting this. Okay. Now I will show you that CD and then output. Okay. So see, so in the netlist there were not these all SEs, a scan enable or a scan in. Okay, so this port was not there in the original netlist. Using DFT we have intentionally inserted this port, this to verify the our design in the later stage. Okay, so these are for the small counter I am using, but in the general case also the same process is happening. It will be a processor, it will be a huge circuit. Okay, so these all process will happen. So for a small circuit I am going through, right. So you have seen what DFT has done. It has inserted a scan flip flop. Okay. So now I'm going to exit this. And these all are STC of that generated scan enable counter, scan flip flop, inserted counter. These all are the five. Now going for that. Now there is now we will go to the folder test, right? So what it is there, you will see. Okay, after the inserting the DFT, we have to verify the uh, like we have to verify our design with the help of a scan flip flop which has been inserted. For this case, we have to we will generate a ATPG data ATPG, and using that we will verify that DFT scan flip flop inserted design. For that the tool which is used is models. Okay, so for models, actually the problem is that the models, the tool which is installed in the server is old version, so that's why it is not working. So I am I will not able to show you the verification step using models. Okay, so sorry for that, but this step you have to remember that after inserting DFT you have to verify that design with the help of models. ATPC is a method like automatic test pattern generation. Like it will generate a test pattern. Using that you can verify your design. Okay, in a scan flip flop inserted design. Okay. So this step is I am excluding. Now I'm going to back, right? Okay, so till now we have seen RTL design. After RTL design, we have verified that RTL using functional verification. After functional verification, we have used coverage. We have seen, and after coverage, we have done synthesis. And in synthesis, already you have generated a netlist. And after the netlist, you have inserted a scan flip flop in that netlist using DFT. Okay, DFT, and then in after DFT you have to verify that design scan enable flip flop using modus with the ATPG method is there, uh, and then what you have to do next, that actually now what you have netlist and you have a scan enabled flip flop. Okay, you have a netlist, all things you have done till verification. Now you have a netlist and you have original design. We have to verify the netlist and original design functionality. For that, logical equivalence check is there. Okay, so in the logical equivalence check, you will verify uh, both the design. So that actually what is happening, if you are synthesizing, you are doing something is optimization is happening. So is the functionality is getting changed due to optimization or not? So for that we will do the logic equivalence check. Okay, so I'm going for logic equivalence check. Now I will show you here. See, so basically we have a, this is counter, original counter RTL, which is written in Verilog, and this is netlist. A scan enable netlist is there, and these are all files. Okay, so for logic equivalence check, I will not go in the more details in this video. Uh, so I am going to open that. So actually what we are doing, we are taking a library, okay, Verilog, and we are taking our original design, okay, golden design, and the netlist design, okay, and we will compare these original design and netlist design, and these all are the steps, these are all are command. Okay, so I'm exiting this. Sorry, actually I'm not able to. Okay, so we will show you in the faster. Yes, yes. Okay, so for logic equivalence check, there is simple command in here, lec, and then do file. Actually do file is used in the logic equivalent. Do file and then your counter dot do. Okay, run it. So guys, if this video has helped you in any ways, then please do subscribe my channel and please share with your friends. If you want to make a video in detail for every stages, please do comment. I will make it for you. Okay. Actually, the same thing will be taught in the some institute. They are taking huge money, 50,000, 1 lakh for learning this step only. Okay, so if you want to learn it in free, just comment it, just subscribe my channel, and I will make for you for every stage. Whenever I will get it done, I will make for you. Now you will see this is a golden design and this is the revised design. And then if you will see the compared, okay, so equivalence check has been done and it is showing that this is 8. All things has been compared. The flip flop is also 8 here. So you are seeing that the both in both cases the all are same. So we can say that the our design, which is uh, generated design, is okay. So we can now proceed further for the physical design. I'm not going in the details. Again, I am telling, if you want, I will make it for you. Okay, so this is the logic equivalence check I have done. Okay. I'm closing this. There are many steps involved. This is very means I'm skipping many things so that I cannot go longer. Okay, so close it. So that's all for this is front end design. Okay. So these all the steps which I have included right now is coming in the front end design. Front end is like a specification, from a specification architecture design. From architecture you have to design a RTL code you have to write, and then RTL code you have to verify that RTL code using functional verification coverage, and then after verification of that code you have to go for synthesis to generate a netlist, and then that netlist should be also verified, and that include one more step is DFT, a scan chain insertion step, and there you have to verify it using the scan chain flip flop, that is with the help of ATTC method. And then after verifying that netlist you have to go for the you have to go for the logic equivalence check. Okay, so logic equivalence check, so these all step comes under the front end design. Now I will make the video for the back end design. It may be of half an hour or maybe 1 hour because back end is very complex thing. Okay, so that's all for today. Be connected with me. Thank you very much for watching this video till now, right now. Okay, thanks.